Wow, welcome again to another day of learning with Mr. Jeremiah Ajali. And like I said, I'll be focusing on Jamb mathematics for now. With time, I can diversify into other subjects, physics, chemistry, but for now, I want to go through maths. I want you to know that repetition is a mode of learning. You have to keep repeating what you have heard from me, what you have watched. Watch the video over and over and over until it becomes second nature to you. You have to keep working on this. You have to keep working. You have to keep working. Don't forget we have a goal to hit 300 in our next Jamb exam. So it is easy, it's possible. All what you need to do is to just keep reading. If you pay the price for 300, you get 300. If you pay the price for 250, you get 250. If you pay the price for 200, you get 200. You only get the goods that you have paid for. So if you pay the price for 300, you get it. And the price for 300 is for you to keep studying and studying and studying. You have to avoid every distraction, plays, friends that won't get you to this destination of 300 right now. Okay. The Bible says in Psalm 37 verse 3 4 and 5, Psalm 37 verse 4 and 5, it says, take delight in the Lord and he will give you your heart's desires. I believe that you want something, you have desires in your heart. The way to make it come to pass, the way to see it bettered is to take delight in the Lord. Delight yourself in the Lord. Get enthusiastic about God. Get happy. Get this joy knowing that God is by your side. Don't be on the wrong side of God right now. You have to be right with God. You have to make your life right with him. You have to submit your hearts to him so that you can get the desires of your heart. It also says commit everything you do to the Lord, trust him, and he will help you. Okay, so that's exactly what we're doing here. We're committing everything we want to do to God because we know he's going to help us. Okay, say after me. As I study today, I commit my ways to the Lord. My plans are established. I am blessed. My memory is blessed. Jesus Christ is Lord and Savior in my life. I have wisdom and understanding from him. Amen. Okay, today's maths we'll be looking at swords, and it's going to be an interesting time. It'll take about an hour also. So buckle up because we'll be going on this ride. Okay. Now, in mathematics, we have what's called rational and irrational numbers. Rational and irrational numbers. Rational numbers are numbers you can put in exact fractions like this. This is a rational number. This is a rational number. Okay. Irrational numbers are numbers that you can't put in exact fractions this way. For example, root 3, root 2, root 5. They are all irrational numbers. You cannot put them in exact fractions like this. You cannot put them in exact fractions like this. So this is irrational. Okay, irrational numbers. Now, solve is the mathematics of roots of irrational numbers. Okay, solve is the mathematics of the roots of numbers. Okay, solve is the mathematics of the roots of numbers. These numbers most of the time are irrational. Okay, so we'll be seeing things like root 2, root 3, root 5, root 7, and all that in swords. Okay, now basically for you to know sword, to solve any question in sword, there are 4 things you need to know. Just 4. If you grasp this 4, you can solve any question in sword. The first of them is addition of swords. Addition of swords. Okay, if you have root n plus root m, okay, it's not the same. If this is not the same as this, you can't add it. It is not the same as root n plus m. You can't add this. You don't add what is inside. Okay, the only way you can add surds is if what is here and what is here is the same, then you add what is outside. So if you have 2 root 5 plus 6 root 5, now I have root 5 here, so you can add this surd, okay, and you add what is outside. So 2 plus 6 is 8 root 5. What I'm trying to say is that if you have root 3 plus root 2, you can't add this. You can't add this. Don't say equal to root, you now add 3 plus 2, 5. No, this is poto mathematics. It doesn't work. It doesn't work. This is, it's not correct. It's not correct. Okay, number 2, subtraction of surds. Just as you have addition, you have subtraction also. Okay, the same rule applies. You can't add surds if the square roots are not similar, or subtract surds if the square roots are not similar. What I mean is, if you have root 8, let me say 7 root 8 minus 2 root 8, you can subtract these surds because this, you have 8 here, similar square roots. So it's going to give us 7 minus 2, 5 root 8. If I say 4 root 3 minus 2 root 2, you cannot subtract this minus this 2. Then you now say 3 minus this. No. This is poto mathematics. It is not. It is not correct. It is not correct. It is not correct. So take note, to add or to subtract, you deal with these values here, checking if these values in the square roots are the same. Those are the type you can add. Okay. The next is multiplication of surds. Multiplication of surds. If you have multiplication of surds, okay, if you have root m and you're multiplying it with root n, it's going to give you root m times n, which is root mn. What I mean is root 2 times root 8 is the same thing as root 2 times 8, which is the same thing as root 16, which is the same thing as 4. Okay, square root of 16. Okay, the fourth is division of surds. Okay, if you know these 4 things, that's basically what surd is all about, division of surds. Okay, if you have root m divided by root n, is the same thing as taking one root m over n. Okay, what I mean is, if you have root 8 divided by root 2, it's going to give you root 8 over 2. Okay, one big root, 8 over 2, and that is root 8 divided by 2, 4, and square root of 4 is 2. Okay, wow, it's already becoming more interesting even at this point. Okay, now dividing surd, it is an abomination for square roots to be at the denominator of a surd. It is not allowed in mathematics for you to have something like 2 over root 2. Having a square root at the denominator of a surdic expression is not allowed in mathematics. So to remove this square root function here, what we do is we rationalize. Okay, we'll go through rationalization of surd. That's what we call rationalization of surd. Okay, rationalization of surds, which is just like dividing surd. So if you have 2 over root 2 and you want to divide it, what you need to do is 2 over root 2. Since you have root 2 here, you use root 2 to multiply the numerator and the denominator. Whatever you have here, use it to multiply this and this. Okay, that's what it means to rationalize. Okay, and that gives you 2 times root 2 is 2 root 2, and root 2 times root 2 is 2, because root 2 times root 2, 2 times 2 is 4, which is root 4, and root 4 is 2. Okay, so generally root a times root a is a. What I mean is root 5 times root 5 is 5. Okay, so dividing sword, you can do that if you have a denominator and it has square root at the bottom. You must rationalize the sword, so you remove that square root at the bottom. As you can see here, after rationalizing it, the square root leaves the bottom. Okay, so let's start answering questions in swords. Now the first question is demanding that we simplify root 45. The first question is demanding that we simplify root 45. Now, the simple trick is to bring a perfect square number from this 45, and 45 is 9 times 5, and 9 is a perfect square number. So this is root 9 times root 5, and that is root 9 is what? 3 times root 5, and that is 3 root 5. Okay. Number 2, simplify root 162. Okay, 162, breaking it down, is 81 times 2. Okay, which should be root 81 times root 2. Root 81 is 9, and root 2 will be left. Okay, number 3, we have to simplify root 20. Root 20 is same thing as what? 4 times 5, which is root 4 times root 5. Root 4 is 2 times root 5. Okay, number 4, we're told to simplify root 32, and 32 is what? 16 times 2. Root 16 is 4, and root 2 is still left. Okay, number 5, we're told to simplify root 200. Root 200 is what? 100 times 2. And what is root 100? 10, and root 2. Number 6, we are told to simplify root x squared y. This is written as root x squared times root y. And what is root x squared? X. And you are still left with this. Okay, so this is how we simplify swords. We try to bring out perfect square numbers so we can make it simpler. Okay, next question is demanding that we simplify root 5 root 18 minus 3 root 72 plus 4 root 50. Okay, so the same principle, bring out the perfect square number. So this is 5 root 18 is what? 9 times 2 minus 3. 72 is what? 36 times 2. Then plus 4 root 50 is what? 25 times 2. Okay, now this is root 9 is 3. Okay, and that 3 times 5 is going to give you 15 root 2. Root 36 is 6, and that 6 times 3 give you minus 18 root 2, which is still left. Root 25 is 5. 5 times this is 20, so that gives you 20 root 2. Okay, so we can add and subtract now, since they have the same root 2 root 2 root 2's. 15 root 2 minus 18 root 2 gives you minus 3 root 2. Okay, then plus 20 root 2 minus 3 root 2 plus 20 root 2 gives us 17 root 2. Okay, the next question wants us to says rationalize 1 over root 5. So to rationalize, I said what you simply do is to multiply the numerator and the denominator with this guy at the base. because it is not allowed for the denominator to have a square root. Okay, so we have not changed anything because this can strike off this and is 1. So it's like multiplying this function with 1. You didn't change anything. But doing this makes the math easier because it removes the square root at the base. So 1 times this gives you root 5. Root 5 times root 5 is 5. Okay. We are asked to simplify 10 root 50 minus 6 root 72 plus root 32 minus 2 root 18. Okay, we're asked to simplify that. So this gives us 10. 50 is what? 25 times 2 minus 6. 72 is what? 36 times 2 plus 32 is what? 16 times 2 minus 2. 18 is what? 9 times 2. Okay, so this is 5 times that, 50 root 2 minus 6 root 36 is 6 times this, 36 root 2. This is what? 4 root 2. Okay, and this is 3 minus 6 root 2. Okay, 50 minus 36 gives us 14. 14 plus 4 gives us 18. 18 minus 6 gives us 12. I can only do that because they are all in root 2s. Okay, I can only do that because they are all in root 2. So you can add and subtract because they are all in root 2s. Okay, hope you're getting it. The next question is demanding that we simplify root 96 plus root 54 minus root 24. Okay, now the same way you break it down, 96 has 16 in there. 16 times 6 is 96 plus 54 is 9 times 6, 9 minus, of course, 24 is 4 times 6. Okay, square root of 16 is 4 root 6 plus square root of 9, 3 root 6. Square root of 4 is 2 root 6. 4 root 6, 3 root 6, 2 root 6, all root 6 we can add and subtract. 4, 3, 7 minus 2, 5 root 6. Okay, the other question is demanding we simplify root 32 minus root 98 plus 5 root 2. Okay, you also break it down same way. Root 32 is 16 times 2 minus 98 is 49 times 2 plus 5 root 2. Root 16, you should know that by now, is 4 root 2. This is minus 7 root 2 plus 5 root 2, all root 2, so we can deal with that. 4 minus 7 is minus 3, minus 3 plus 5 is plus 2, so have 2 root 2. Okay, please, if you have any question, online, I have accounts with the various social network, on Twitter, on Facebook, on Instagram. You can get across to me to ask me questions. I'll be very willing to answer you. So you can get to me. That's all I'm trying to say. Now the next question is saying we should simplify root 50 minus 3 root 2 multiplying 2 root 5 minus 5 minus 5 root 32. Okay, so break down still. 50 is what? 25 times 2. Okay, now this is multiplying this, so have to multiply. This 3 has to multiply this 2. and this 2 in the square root has to multiply this 5 in the square root. Okay, so minus plus gives us minus. This 3 goes to multiply this 2 outside to outside, inside to inside. Okay, 3, 2, 6, inside to inside, 2, 5, 10. Okay, then we have to multiply this 2. Minus minus gives us plus. Okay, 3, 5, this only has outside, is going to give us 15 root 2. Okay, because this has an invisible root 1 here, so 2 times 1 gives us 2 still. Okay, minus 5 root 32. Okay, we should break this down to be 16 times 2. So this is 5 root 2 minus 6 root 10 plus 15 root 2 minus 5 root, this is 16 times 2, right? Yes. So this is 5 root 2 minus 6 root 10 plus 15 root 2 minus, this is 4, square root of 16 is 4 times this is 20 root 2. If you look critically, you can add these. You can't add this to this because this is root 2 and this is root 10. But you can add this 2 and it's going to give you what? 20 root 2. 20 root 2 minus 20 root 2 is 0. Okay, so what are we left with? Minus 6 root 10. Okay, so that's the answer. The other question is demanding that we simplify. The other question is demanding that we simplify 3 root 12 plus 10 root 3 minus 6 root 6 over root 3. Most of these questions are from the past question. It's just that I can't just be mentioning all the years, but they are past questions from Jamb, so it's related to you. 3 root 12, you can break this down. Okay, and here you have to rationalize, because I told you it's an abomination for square roots to be at the denominator, so we have to rationalize here. So let's do that by the side. 6 over root 3, to rationalize, you multiply by root 3. This times this is what? 6 root 3 over this times this is 3. This gives you 2 root 3. So this is 2 root 3 here. Okay, and 12 is what? 12 is 4 times 3 plus 10 root 3. We have simplified this and is what? 2 root 3. Okay, so this is root, square root of 4 is 2. 2 times that is 6 root 3 plus 10 root 3 minus 2 root 3. This plus this is 16. 16 minus 2 is 14 root 3. Okay, that's simple enough. This other question is demanding that we solve 2 root 14 2 root 14 times 3 root 21 divided by 7 root 24 times 2 root 98. Okay, now to multiply, you multiply outside to outside, 2 times this time, so you multiply 2 times 3 6, then inside to inside 14 times 21. Okay, then this outside to outside 14. Okay, inside to inside 24 times 98. Okay, this division of sorts if you look carefully, so this can be written as 6 over 14, 6 over 14, 1 square root 14 times 21 over 24 times 98. Okay, we can cancel here. 2 here is 3, 2 here is 7, so I have 3 over 7, 1 big square root, 14 times 21 over 24 times 98. Okay, we have to look for a means to cancel. We have to look for a means to cancel. 3 here is 7. 3 here is 8. Okay, 7. Okay, 7 can go. 7 here, 1. 7 here, 1. Remaining 2. 28 is 4. Wow, 14. 14 here, 1. 14 here, 1. So we're left with 3 over 7 roots 1 over 8. Okay, and this is the same thing as 3 over 7 times root 1 over root 8. Root 1 is 1, of course, which is 3 over 7 root 8. Okay, now like I said, it's an abomination to have square root at the denominator, so we have to rationalize to take the 8 up. Okay, we have to take the 8 up, so that is 3 over 7 root 8 times root 8 over root 8. We could have broken root 8 down actually to be 4 times 2. We'll still get the same answer. So this is 3 root 8 divided by 7 times 1, 7. Root 8 times root 8 is 8. Okay, and that is 3. Root 8 is what? 4 times 2 over 7 times 8. Root 4 is what? 2. 2 times that is 6 root 2 over 7 times 8. Okay, 2 here is what? 3. 2 here is 4. That gives us 3 times that is what? 3 root 2 over this times that is 28. Okay, that's 28, and that's the answer. Okay, it's simple. The major thing is just canceling out and simplifying. It's very simple to go with. Okay, so we are proceeding, and I like our pace because it means we should cover up before an hour. Okay, there's what we call the conjugate of a sword. Conjugate of a sword. What it means is, if you have root a plus root b, the conjugate of this sword is simply a. If this is plus, it should be minus here. So the conjugate of this sword is the same sword when this sign is changed. If it is plus, this should be minus. If it were minus here, you change it to plus. So the conjugate of this is this. Okay, then if you have root a minus root b, the conjugate of this sword is root a plus root b. It's just change the sign here, that's all. Okay, now we have to use the conjugate when we want to rationalize swords like this. The next question is asking us to rationalize 1 over root 2 plus root 5. Okay, now you can see in this sword that there's also square root at the denominator, so we have to remove it. It's not allowed. Now to do that, you multiply numerator and denominator by the conjugate of the base. Okay, and looking critically, what's the conjugate of this base? The conjugate of this base will be this. We have to change to negative, so you have root 2 minus root 5 divided by root 2 minus root 5. You didn't change anything because if you divide this, you get 1, and 1 times this is this. Okay, you didn't change anything. It's still consistent in mathematics. So let's multiply. 1 times all this gives you the same thing. Okay, then let's go. It's like opening bracket. This times this is going to give you 4 root 4, which is 2. Root 2 times root 2 is root 4, which is 2. This times this is minus root 10. This times this now is plus root 10. Then this times this is minus root 25, which is 5. So this gives us root 2 minus root 5 over, this is 2 minus root 10 plus root 10 minus root 25 is what? Is 5. Okay, 25 is 5. Now you see minus root 10 plus root 10, it will cancel off. Okay, at every time you multiply a sword by its conjugate, this will always happen. This will always happen. So it leads us to root 2 minus root 5 divided by 3. 2 minus 5 is minus 3. Okay, so that's the answer, or you can turn it so the minus will cancel to be 5 root 5 minus root 2 over 3. Okay, bringing out the minus and cancelling. Get that? Okay, so there is something you need to know about multiplying with a conjugate. It's very simple, so that next time I want to multiply, it will be easier. If you have root 2 plus root 3 and you multiply it with its conjugate, root 2 minus root 3, the answer you will simply get will be this times this, which is 2, minus this times this. This times this is 3. So this will give you minus 1. That's the short way to do it, because these two functions must always cancel out at every time. Okay, so the simple way is you say this times this, you get it, then this times this, you get it. Minus is always minus, so this times this minus this times this. Okay, so remember that, because we'll be using it from now. Okay, the next question is saying we should rationalize 5 root 7 minus 7 root 5 divided by root 7 minus root 5. Okay, so you multiply numerator and denominator with the conjugate, and the conjugate is what? Root 7 plus root 5, root 7 plus root 5. Just change the sign. If this was minus, change it to plus. Okay, now when you multiply, for the denominator is simple, because it will be this times this, 7, minus this times this, it's 5. So the answer is 2 at the denominator. So what we need to do now is to multiply this numerator part. It's like you're multiplying, opening brackets, same way. Say this times this times this, then you now go this times this times this. Okay, so this times this first, 5 to this gives you 5. Root 7 times root 7 gives you 7. So 5 times 7 is 35. Okay, we'll now do this times this. 5 times outside to outside, which is 5. Then 7 to 5 gives you root 35. Okay, then we'll come to this times this. 7 of course minus, which is minus 49. Then 5 7 gives us 35. Okay, then we'll now say this times this. Minus 7 root 5 is 5, so minus 7 times 5 is minus 35. Okay, so we have 35 minus 35, it cancels. We have 5 root 35 minus 49 minus, what did we do here? We wanted to get this times this. Oh, there is 1 here now. It can't be 49. This times this is 7. Where did you get 1 from, Jerry? This times this is 7. Okay, is the 5 times 7, that is 35. Sorry about that. Okay, so so it will be 7 root 35 divided by 7 minus this is 2. Okay, so 5 root 35 minus 7 root 35 gives you minus 2 root 35 over 2, and this can take care of this to give you minus root 35. It's just being careful not to make mistake. You surely get it. Okay, the next question is demanding that we simplify. It says simplify 1 over 3 plus root 5 minus 1 over 3 minus root 5. Okay, simplify that. This is like LCM, so we'll take LCM of 3 plus root 5 and 3 minus root 5. That's the LCM, the two bases. This into this, if this cancels this, you'll be left with this. So this times this gives you 3 minus root 5 minus this into this cancels, you'll be left with this times this gives you 3 plus root 5. Okay, and this is 3 minus root 5 open bracket minus 3 minus root 5. Minus goes through, divided by conjugate. Yes, so it will be this times this 9 minus this times this 5, and that gives us 3 minus 3, 0, minus root 5 minus root 5 gives us minus 2 root 5 divided by what? 9 minus 5, that is 4. So can't we have minus root 5 over 2? Okay. The next question is asking and demanding that we also simplify 4 minus 1 over 2 minus root 3. Okay. Yes, that's what it's demanding. It's demanding we do that. Now, if you also look critically, this is like LCM. So we can take LCM of this to be 2 minus root 3. This is like over 1. So 1 into this is this times that gives us 4. 2 minus 3 minus this into this is 1, and 1 times that is this. So that is open bracket. It's going to give us this. This is what? 8 minus 4 root 3 minus 1 over 2 minus root 3. Okay, 8 minus 1 gives us 7 minus 4 root 3 over 2 minus root 3. Okay, now it's an abomination for square root to be at the denominator, so you know what we should do? We should rationalize. So multiply with 2 plus root 3 over 2 plus root 3 plus, because it's minus here. Okay, so to do the denominator is easy now. This times this, 4 minus root 3 times root 3 is 3. Okay, so let's do the numerator. 7 times 2 is 14. 7 times this is 7 root 3. This to this is minus 8 root 3. This to this is root 3. Root 3 gives you 3. 3 times minus 4 gives us minus 12. Okay, 14 minus 12 is what? 2. 7 root 3 minus 8 root 3 gives us minus root 3 divided by 4 minus 3 is 1. So divided by 1 gives you that same thing. Okay, and that's the answer that was gotten. Okay, given that, next question, it says given that root 128 plus root 18 minus root k is equal to 7 root 2. Okay, we're told to find the value for k given that this expression is valid. Okay, now we have to break this down also. If you look here, 128 is 64 times 2 plus 18 is 9 times 2. You, with time, as you keep on solving log, you'll be able to see these values. These numbers keep repeating themselves. You just know when you see that 128 is 64 times 2. It is out of practice, it becomes used to you, you know. So minus root k is 7 root 2. Okay, so this is 8 root 2. 9 is what? 3 root 2 minus root k is equal to 7 root 2. This to this gives you what? 11 root 2 minus k, which is root k, is equal to 7 root 2. Let's take this here so it will be positive. We take this here, we'll have to take this in. So taking this in to be minus. So 11 minus 7 is what? 4 root 2 is equal to, take this over, it's k, root k. Now you have root here. When you have root on both sides, to remove the root, you square both sides. Okay, you square both sides. If you square 4 root 2 square, if you square root of k, it's going to give you k. Okay, it's going to give you k. So let's square this to see what we get. Square this means multiply this by itself. So 4 root 2 times 4 root 2, this is 16 times this is 2, which is 32. Okay, so it means k is equal to 32, and that's the answer. Okay, now look at this other one. It says we should simplify 10 over root 32. This is simple. This is simple. We just rationalize 10 over root 32 times root 32 over root 32, which is 10 root 32 over this times this is 32. So what do we do next? We have to cancel. Okay, before we cancel, let's deal with root 32. 10 root 32 is what? 16 times 2 over 32. This is 4 times this is 40. 40 root 2 over 32. 8 here is 5, 8 here is 4. So 5 over 4 root 2. Okay. It's becoming more interesting right now. We are to, the next question is demanding we find the value of x. The next question is demanding we find the value of x if, find the value of x, we want to get x if this expression is valid. Okay, we want to get the value of s if this expression is valid. Now remember, this means square root of x plus 4. This is square root, raised to power 1 over 2 means square root, minus this is also square root of x minus 1 is equal to 1. Okay, now to remove these square roots, you have to square both sides. You have to square both sides. Squaring both sides means root x plus 4 minus root x minus 1, which is this, square 2 times. It means 2 times, so you multiply this 2 times. Okay, it's root x plus 4 minus root x minus 1. Okay, is equal to, if you square 1, it's 1. You square this side 1, you square this side, this is what you have, multiply 2 times. Okay, so multiply, use this to multiply everything here, use this to multiply everything here. So let's go. This times this is like root a times root a, to give you a. So x plus 4 will be left. Okay, then this times this will give us minus root x plus 4 x minus 1. Okay, then this times this will give us minus root this x plus 4 x minus 1. Okay, then this time this will give us plus, because minus minus is plus. This is like root a, it will still give us a. X minus 1 is equal to 1. Okay, now you can add this. X gives you 2x, 4 minus 1 gives you 3. Okay, then this is minus, if you look at these two brackets, they're the same, so minus 1 gives you minus 2 root x plus 4 x minus 1 is equal to 1. Let's take these over. We're having minus 2 into x plus 4 x minus 1 is equal to 1 minus 2x minus 3. I just took these two guys over, it changed to minus. This gives you what? Minus 2 minus 2x. This is minus 2 minus 2x. And if you look critically, minus 2 is common here. It gives us 1 plus x. Okay, is equal to minus 2 root x plus 4 x minus 1. Minus 2 takes care of minus 2 here. We're left with x plus 4 x minus 1 is equal to 1 plus x. Some questions like this, after you square the first time, the square root will leave, but some other questions, the square root won't leave for the first time, so you have to square again for it to leave. Like if you see there's still square root, meaning we have to square again. So we have to square again. Okay, so we have to square again. We have to square again, square both sides again, square both sides again. Okay, so if you square this side, square root of x plus 4 x minus 1 square, then square this side, 1 plus s square. If you square a square root, the square root will go, so we'll be left with x plus 4 x minus 1 is equal to You square this side, you are going to get square the first term, square the first term, square 1 plus 2 times this times this. This is a simple way to square a function of such. 2 times 1, 2 times this, 2x, square this term, 2x, square this term, which is x squared. Okay, it's simple. Square the first term, square this, 1, then 2 times this times this, 2 times 1 times x, 2x, square this last term is going to be x squared. Okay, so let's expand this. This gives us x squared, this gives us minus x, this gives us plus 4, this gives us minus 4 is equal to 1 plus 2x plus x squared. Okay, x squared, x squared. Okay, we're left with there's an x here, this x squared, this minus x, this minus 4x. Okay, so this gives us 3x minus 4 is equal to 1 plus 2x. So let's take this in and take this out. So 3x minus 2x is equal to 1 plus 4, and then 3x minus 2x gives us x, and 1 plus 4 gives us 5. Okay, it's easy, just square both sides. That's all you need to do, square both sides. Okay, just square both sides. The next question is demanding that we find the square. We want to look at square root of a surd. I want to look at square root of a surd. Okay, the question says find the square root. We should look for find the square root of 8 plus 2 root 15. Okay, find the square root of 8 plus 2 root 15. Now this is a special kind of surd type. You have to open your ears right now to understand. What I'm simply saying is that you should look for the square root of 8 plus 2 root 15. Okay, you want to look for this square root. Now when you look for this square root, you will have an answer that will be in this form. A and B you don't know, but the answer will definitely be in this form. A might have a square root, B might have a square root. If it's not supposed to have a square root, then even root 4 plus root 3 still boils down to having a square root, because this is 2 plus root 3. What I'm trying to say is that if at the end of the day the answer when you square root this is 3 plus root 2, what it meant is that this is root 9 plus root 2. So when you square root this surd function, the answer will always be in this format. That's a simple trick. That's all you need to know. Okay, so if I can get A and B, then I have found the square root of this number by just substituting A and B here. Okay, so how can I get A and B? This is square roots. So if I want to remove the square root, I will square both sides. Okay, square both sides. So if you square this side, this square root will go. You'll be left with 8 plus 2 root 15 is equal to, we want to square this side. We want to square this side, root A plus root B square. We want to square this side. If you square this side, it will cancel the square root. So that's why the square root leaves. Okay, so let's square this side. It is root A plus root B multiplying root A plus root B. Now take note, this pattern will always repeat itself. It will always repeat itself, so just observe it. It will always be in this form. This times this is A. This times this is plus root AB. This times this is plus root AB. This times this is plus B, and that gives us A plus B, which is this 2, plus this is 2 root AB. Okay, 2 root AB is equal to this, of course. Okay, now if you look, this side doesn't have square root, just like this side, this guy here doesn't have square root. This guy is half square root, which is like this guy that has square. So you can compare. It means a plus b is equal to 8, equation 1. This is equal to this, and this is equal to this. 2 root ab is equal to 2 root 15, which is equation 2. By comparison, it means ab is 15 here. ab is equal to 15 by comparison. Yeah, if this is 2, this is 2, this is root, and I have ab here, it means this should be ab. Okay, so this is equation 2. From equation 2, a is equal to 15 over b, right? From equation 2, a is equal to 15 over b. So I have equation 1 and equation 2. Let us substitute that value there. Okay, a plus b is equal to 8, equation 1. Then from equation 2, we have said a is equal to 15 over b. So substitute it into equation 1. It means anywhere I see a, I'll put 15 over b plus b is equal to 8. In place of a, I put 15 over b here. Okay, so multiply everybody with b so that this b leaves. 15 plus multiply this with b, b squared is equal to multiply this with b, 8b. Okay, which is b squared, take this in, minus 8b plus 15 is equal to 0. Okay, that means quadratic equation 5 times 3 is this. I need minus, so minus 5 minus 3 gives me this. These are the factors, meaning that b is equal to, don't forget how I taught you how to solve this quadratic equation easily. Negate the factors. Negate 5, you have 5. Negate this, you have 3. Okay, negate means if it's plus, make it minus. If it's minus, make it plus. Minus change to plus, minus change to plus. That's what it means to negate. Then divide with the coefficient of b squared. Here is 1, so you divide with 1, you still get the same thing. So b is either 5 or 3. Now if this is b, it means that a would be, when b is 5, if you put 5 here, to be 15 over 5, and that is 3. So a is 3. I've left the region. Okay, so solving, you have b is equal to that. Now if a is if b is 5, put b here, put 5 here. Putting 5 here, you'll be getting 15 over 5, and that's 3. So a is 3. Or when b is 5, when b is 3, put 3 here, 15 over 3, that is 5. So a is this when b is this, and a is this when b is this. So we can now simply say from what we are trying to solve from this, this is what we're trying to get, that the square root of that guy is root a plus root b. The square root of what we're looking for is root a plus root b. But we have solved for that now, meaning that the square root of that expression is root a is what? We can take this first case when a is 3 and b is 5. When a is 3, b is 5, 3, 5. Or you take the second case when a is 5, b is 3. Either of them is correct. Okay, either of them is correct. The square root of that number is either this or this. You only see one answer in the option, so any of them you see, you pick it. That is the answer. Okay, we have about 5 more minutes, so let's still try to solve one more question under square root of sorts so that it will sink in better. Now the question says we should find the square root of 170 minus 220 root 30. Find the square root of this. Okay, we say the square root of this will give us an answer that looks like this. Now since this is minus, now this will be minus here. Unlike the other case, it was plus, so we'll put plus. When it is minus, you put minus here. Okay, so to remove square root, square both sides. So square both sides. Okay, to square both sides, the square root leaves 170 minus 20 root 30 is equal to, if you square this side, it's going to give you, square the first, 2 times this gives you minus 2 root ab, square the second, b. Okay, if you square this, that's what you get. That's the short way to do it. 170 minus 20 root 30. Now by comparison, a plus b minus 2 root ab is this. By comparison, these guys that don't have square root is that, so a plus b is 170 by comparison. Then this guy that has square root is this, minus 2 root ab is minus 20 root 30. So this is this, as this is this. Okay, now this is equation 1. Now this is equation 2. Let's simplify. Minus cancels minus first. We have 2 root ab is equal to 20 root 30. This here 1, this here 10. So root ab is equal to 10 root 30. To get ab, we square both sides. So if you square here, you have ab. If you square, you have 100. Square this is 100 times 30. So AB is equal to 3000. AB is equal to 3000, meaning that A is equal to 3000 over B. So if we substitute this into this, we'll be having, in place of A, we'll be having 3000 over B plus B is equal to 170. Okay, multiply both sides, everything by B. 3000 plus b squared is equal to 170b. Take this in, b squared minus 170b plus 3000 is equal to 0. Okay, 150 times 20 is that. I need minus, so minus minus. This is this now. So b is negate. Now if you substitute these values into a, you see that a will just be 20 or 150. When b is 150, a is 20. When b is 20, a is 150. Okay, so it means the square root, the square root of what we are asked to get, 170 minus 20 root 30, is equal to root a minus root b. Okay, meaning is root, what is a? For the first case, when a is 20, b is 150. Or for the second case, when a is 150, b is 20. Okay, so this or this, any of them, it's the answer. Okay, now there are some questions that will simply ask you, find a positive square root. If the question is demanding for the positive square root, if it's saying find a positive square root, you know every square root has plus and minus. Okay, so if it's asking for the positive square root, it means you should look for the function that will give you plus, a positive answer. If it's asking for a negative square root, either of these two, one will give you a negative answer, one will give you a positive answer. Okay, now if you look critically, the root of 20 is 4 point something, minus the root of this is about 40, close to 40, let's say 38. This minus this would give you a negative answer. So this is the negative square root. This answer is a negative square root. Then if you look at this will be about 38 minus 4. This will give you a positive answer. So this is the positive square root. So if you are asked to look for the positive square root of this is the answer. If you are asked to look for the negative square root of this is the answer. Okay, but if they just say find the square root of this, then they can only put one of these answers and you pick any of them that you see there. Okay, this is about an hour and it has been a great time being with you. Don't forget you can follow me on the various platforms, and I still remain Mr. Jeremiah Ajali. Tell me what you see, tell me what you expect. If there is any topic maybe you're having challenges with, let me know. Tell me, I will handle it. I can easily treat it because of you. So talk to me. I want to get responses from you. I want you to relate to me. Tell me how you're preparing for Jamb. Tell me your desires. Talk to me because I'll be here too. If you have any challenge in terms of the course to fill, any challenging situation in your in your academic life, you can talk to me and I will also see how to help out. Okay, so it was a wonderful time being with you. I enjoyed this class. Once more, thanks for listening to me. I hope to see you at the top. Don't forget, we're targeting 300. Thank you.